Wonderful. So welcome, Dr. Lindsay Robertson. Lindsay Robertson has an academic background in mechanical engineering design and thermal systems from Canterbury University in New Zealand, and also a PhD degree focused on technological risk exposure and resilience from the University of Wollongong, Australia. And I'd like to welcome Dr. Robertson to speak on vulnerable infrastructure, secure infrastructures. And over to you, Lindsay.
All right, well, Rob has done a very good job of introducing me. And the only thing I'll add to that, I'm a New Zealander by birth, and in fact, I could go further, and I'm from Dunedin, which is in Otago. Okay, so basically, I'm going to track through, go through a bit of an introduction. I'm going to look at some infrastructural vulnerabilities. There's a degree of overlap with what Louis Kuhn has already covered, but I'll perhaps try and bring some slightly different perspectives where they're appropriate, and where they're not, I'll just blast on fairly quickly. Go on and look at the categorisation of vulnerabilities, take a less gloomy view and look at vulnerability reduction, and finish up with a few questions on multidisciplinary approaches. I think I'll be focusing on what's perhaps not quite the traditional infrastructure, but of course, infrastructure is a poorly defined term. As Louis Kuhn has said, we've both said, infrastructure is not just buildings, roads, energy. There's actually quite a wide variation amongst countries as what is considered infrastructure, or what in fact is considered critical infrastructure. And I guess I'll just really look at a definition of permanent capabilities that are needed for societal functions. But the important point, and it's pretty obvious, but it bears restating, is that we've got an increasing proportion of population living in urban areas. And while the rural areas are still vulnerable to infrastructural failures, people living in urban areas have rather less options. And so the dependence and the vulnerability on infrastructures has tended to go up and will go up further. Key feature in the development of infrastructure is really being driven by economies of scale. These have evolved highly centralized infrastructure. And that's got two or three real consequences. And again, these are in some ways blindingly obvious, but I think they're worth actually restating. First is, as large numbers of people are vulnerable to failures, and there's a level of insecurity that arises out of that. There's also what I'd call an asymmetry of consequences, where large numbers of people, or moderate numbers of people, may have very, very large effects on their lives. It may not have a lot of effect on the infrastructure owner, and that affects the way that the owner and the clients, as they were, interact. Possibly one of the more important points that I'm going to carry all the way through, and it's one I think we need to do a little bit more academic effort on. Reliable systems mask vulnerability, and they mask lack of resilience. We can have very, very reliable systems that still have underlying vulnerabilities and have not very good facilities for resilience. The theme of the conference includes this transdisciplinary aspect, and I guess I'm trying to perhaps also just note some of the points that were made by Holger early on, and that there are people involved as well as technologies. Perception of security is linked to perceptions of vulnerability, and I think we've actually seen quite a few evidences of these, particularly in the COVID era. Stockpiles of food were rather interesting. And the news item recently here absolutely surprised me when there was a survey done of how much cash people were often keeping about themselves. And one can only assume that that's because of an underlying insecurity about whether their banks are going to continue to operate. Probably appropriate, actually say a lot on press for encryption. Well, that's been somewhat covered already. Rather interesting reactions. You may have noticed recently that when Twitter was taken over by a certain person, all of a sudden there were, I think, many, many tens of thousands of people straight away move to the decentralized open source Mastodon social media facility. And I think that's probably evidence of an underlying sort of feeling of uncertainty and vulnerability. So, all right, I'll keep trucking fairly quickly and look at some examples. What I'm not going to spend a lot of time on is what I'd call the traditional infrastructures, the buildings, roads. The reason I'm not is not because they're not important, but they're very, very well covered elsewhere. There are at least 3 journals that are devoted to critical infrastructure protection, and structural matters. There's also organisations like SRA and IAIA looking at risks and impacts. And so I don't really want to track into those areas. They've done it far better than I possibly could. But I do want to try and take an SSIT type lens on the whole thing. So let's look at some examples. In the electrical field, a year or so ago, Texas, the state of Texas, came within minutes of a complete shutdown. Had that occurred, it was in a winter where the temperature was about -10. The consequences for that state would have been really quite high. The cause was actually, well, the thing that came close to causing it was actually well known. It was water and gas lines precipitating and freezing valves up. Second one on the right-hand side, again, an article from a little while ago, a couple of years ago, talking about the vulnerability of, sorry, let's rephrase that, talking about the dependence of some very large bespoke electrical transformers. These are not the sort of things that one can wander down to Radio Shack and buy. These are bespoke, taking months to make a new one. But I want to make a point here, which I hadn't intended originally, and just to, I guess, reflect back on Louis Kuhn's material early on. I think we've got to take quite a nuanced view here. An electrical shutdown often can be restored in really quite a short time. Had the Texas power crisis happened, in other words, had there been that cascading failure, it would be difficult to bring CCGT systems or Rankine cycle systems back up. There'd probably be only a few of them that had a black start capability, but you'd be talking about a matter of days. On the other hand, if you've got a large bespoke component that has failed, you may be talking about a period of months. So that sort of nuance needs to be looked at. I published a paper in about 2010, and in hindsight, it's a bit amateurish, but I tried to look at, for several possible failures, what was the difference between the time that is required to repair something and the time interval during which either the thing would become critical or the failure would cascade. And there were some things where there was really quite a large ratio between those, and a lot of things where there was not a large ratio. And that's a distinction that I think is worth actually looking at. The undersea fiber optic cables has already been referred to. I think it's worth just putting a little bit of weight on that. Something like 98% of internet traffic is carried on those undersea cables. I will actually refer to Starlink later on, but I think it's important that any thought that there are viable alternatives to those undersea cables, not in the practical sense at the moment. Incidentally, I should have said early on, I'm certainly not making any political points or around this slide at all, but I think we should just also be not naive about the threats to things like those undersea cables. And I've picked 3 examples, all from public media here, of man-made threats. And down in the bottom left-hand corner, I've also grabbed a well-publicized photo of one of our more primitive animals that apparently took a philosophical objection to one of Google's cables. I presume the shark wouldn't have minded the Apple cables, but anyway, that's what he did. Anyway, the point is there are man-made and there are natural hazards to some of those critical infrastructures. We've seen the pictures of the Ever Given container ship stuck in the Suez Canal for many days. The interesting point there is, after it happened, news media said, look, we knew this was going to happen. The momentum of the ships was such that they were marginally navigable. We knew it was going to happen, but hey, it just happened anyway. GPS, not just used for positioning, used for timing signals. In fact, the timing is used actually quite widely. That one is perhaps becoming less critically vulnerable because there are more than one player, independent player in the field. Global chip supplies. Again, whether one calls that infrastructure or not, I won't debate the point. But TSMC has something like 30% of the global supplies, and shortages of those we're seeing in the news media. They're affecting all the way through to vehicle production, having quite a wide effect. Rare earths, I've mentioned there as a vulnerability, and I guess you'd call that technological. They go all the way through from things like erbium for the boosters and the undersea cables to the samariums and the magnets in your headphone. But it's not only the rare earths. We've also got, I think, some quite vulnerable points with things like helium used in medical applications, and also lithium actually to be proposed for batteries. Oops, did I? Oh, dash. Rather more recently, we've seen the news items on the North Sea pipelines. And the interesting comment there that popped up in the news media was that there were hundreds of kilometres of these pipelines undersea, and it was basically impossible to, in any real sense, secure them. Not long after that, of course, there was also a news item showing this undersea power cable running from Egypt to Greece. And I haven't seen any comment on that, but it's pretty obvious. So look, I want to move on. I want to move on fairly quickly and try and put these vulnerabilities into some categories, not just for an academic point of view, but because if you categorize them, you can start and look at the root causes, and you can also start to look at approaches to reduction. So I guess there are a number, and I've grouped them up. Some of them are pretty obvious: the systemic risks, the communication, and the finance. The scarce initial resources, which I've mentioned already. Complex or high capex unit operations, and the chip fabs are in that category. Lack of buffering or single points of failure. And they're all the obvious ones. The slightly less obvious ones, I want to mention what, for lack of a better term, I've called contributory systems. The example there I would use is a industrial process where you have a straightforward control system, and somebody decides to make input from the internet an unavoidable part of that control system. So the control system originally would have had a certain vulnerability, but all of a sudden, by making an input from the internet essential, that control system acquires all the vulnerability of the total internet system. So that increase in vulnerability has been added by a contributory system. Centralized processes I've mentioned already. Lack of segregation, vertical segregation, so that there are no points where a competitor can come in or an alternative can be provided. Very closely linked to proprietary interfaces, and what I've called practical unavailability, which I'll spend a little bit more time on now, if I can get to the next slide. And again, I say I don't want to make any political points here at all. I've simply chosen some examples. What I would call practical unavailability is where the technology is available and hasn't changed, but for some reason the technology has actually become unavailable. And I'll leave those to speak for themselves, but there's another one that's been popped up quite recently, and I think it's very interesting. You'll notice that the Starlink system was used quite extensively in Ukraine until somebody who owned the Starlink system decided to turn it off for Ukraine, later turned it back on again. But I think the point is that there was a system that technically was working, but where there was a vulnerability that wasn't technical, it was just somebody who for his own reasons, decided to turn it off. Particular systems with high vulnerability or high population exposure, and again, this is tracking over the same thing, just looking at, I guess, from a slightly different way. The high voltage power systems and the centralized generation, GPS chip fabs, pharmaceutical active ingredients, undersea cables and comms, centralized fuel. The financial transaction systems would be right up there in my view in terms of our centralized systems with high population exposure. And I guess really tracking back over in perhaps a little bit more detail, we've talked about the scarce resource dependence, complex components. We don't, again, I think it's important to look not at electronics, which is perhaps a slight tendency to look at. The gas turbine motor, RO membranes or batteries would be in the same category. Energy conversion and storage, that's in my view one of the major technology gaps in society, with the exception of hydrogen carriers, pumped hydro and biofuels. We actually don't really have very good energy storage, and that lack of buffering then translates into vulnerability. So that's been a bit of a doom and a gloom, exercise, and probably just as well to move on from that, take a slightly more hopeful approach and look at possible ways that we could look at vulnerability reduction as it's applied to infrastructure. And I guess this is also where these transdisciplinary and people versus straight technology approaches start to become really important. Try and avoid vertically integrated systems, advocate for standard interfaces, so where one can have alternatives or substitutes being provided so that one failure doesn't simply cascade to another. Secondly, consider a hierarchy of needs and resist changes that will affect more fundamental needs if they serve the higher needs. And I guess some of the ones around privacy and encryption fall into that category, that yes, we want a higher need, but we need to preserve the privacy and the security at the more basic need as well. And I've already mentioned the practical unavailability. For the durable infrastructure, the buildings and the roads, I think probably the most effective approach still is design standards and redundancy. For some of the control type systems, don't lock in contributory systems. In other words, make possible manual input rather than absolute dependence on some internet input or something else. Retain fallback systems. And I'll pick on an example here, not because I'm flogging a hobby horse at all, but just simply to illustrate the point. Most banks are now stopping accepting and issuing checks. The interesting point there is if I've got a bit of paper in my hip pocket and a ballpoint pen and perhaps a check guarantee card, that day-to-day commerce could continue even with lack of internet, lack of cell phone, lack of anything else. Dealing with checks cost the banks money, so they got rid of them. That was fine from their point of view, but all of a sudden a technology system that was completely independent of the electronic one and therefore was a genuine backup ceased to exist, and we've lost a backup. Final point there, and it'll lead on to the next slide, is look at and adopt democratizing technologies. I've referred to this in a paper in Futures a little while, last year, I think. Yeah, last year. Technology developments are actually, there are a number that I would put in the category of democratizing technologies. And the 3D printing movement is actually really starting to allow complex components to be made close to point of need and be made from libraries of specifications. So it's actually breaking down some of that highly centralized manufacturing. There was the well-publicized case a couple of years ago where high school students managed to synthesize daraprim. And again, some of those molecular assembly, for lack of a better word, capabilities are actually also bringing complex components from a highly centralized one place down to a much more local area. We're also seeing decentralized social media. I mentioned that once before. Whatever one thinks of cryptocurrencies, the driver behind that was a decentralizing of financial transaction capability. And of course, the open source software and hardware, I think it's worth mentioning there that we've already got some gains there. We've already got, for example, almost complete agreement on ASCII or perhaps Unicode. And we've also got slowly tracking towards some agreement on document formats, but there are still quite a lot of vertically integrated and inaccessible vulnerabilities in there, particularly storage of information. All right, pretty close to the end, wrap up and talk about multidisciplinary approaches. Oops, if I can go down. Right at the start, I said that the drivers for vulnerable infrastructures tend to be, I think you probably boil most of them down to economies of scale, cases where there is a minimum initial expenditure, such as the undersea cables. But these always have an outcome in asymmetric consequences, where the person at the end of those systems and who depends on them suffers a severe consequence if they're not available. The person who owns those technological systems really suffers very little loss if one person loses access. And that sort of flows its way down to a whole attitude thing. How can society avoid that sort of vulnerability and that sort of insecurity? Well, I think SSIT has some real answers there. We need to talk about perceptions of risk. Are people actually aware of the level of vulnerability of the infrastructures that they depend upon or not? And that's taking a sort of a qualitative view. And I've done some work on trying to get some quantitative measures of vulnerability, but I'm very, very keen to find collaborators for that sort of work, because really, I think once we can start and get past the exemplars and the glossy slides and actually say, right, the focus needs to be on A rather than on B, then that's a really valuable contribution. So take-home points. Infrastructure vulnerability is large, and I think it is actually growing rather than decreasing despite the democratization. Just a straight risk focus is not adequate. Reliable is not the flip side of robust, reliable does not mean robust and does not mean secure. Third point there, hardening is not a long-term solution, I don't believe. I think you're into whack-a-mole territory. You cure one thing and something else pops up, and you cure one thing and something else pops up. We need to think technically about how do you get long-term solutions, and I think that probably comes down to standardized interfaces, decentralization, and approach strategies rather than tactics like that. We need better analytical approaches, and I've said I'd be interested in collaborations. Certainly, I think that the vulnerability can be reduced by multidisciplinary approaches, but there are social and economic issues. Quite a lot of those vulnerability reduction approaches cost money, and we've become very used to getting an awful lot of services for minimum cost. And in the case of the internet, some of them for free. And realistically, I think we have to grapple with that social and economic issue as well as the technical issue. So I've done more than enough talking, and I'll probably not too far off in timing. I'll leave it there. Thank you.
Thank you so much, Dr. Lindsay Robertson. Perfect timing and such a clear and nuanced presentation around infrastructure vulnerability, the asymmetry of consequences, the consequences on the end user and what society can do about that. I really appreciated the emphasis again on perceptions of security, talking to Professor Kun's points around perception earlier on, and also so much to think about in terms of multidisciplinary approaches and the role that SSIT and other such communities may have in that regard. I do want to hand over for a brief reflection to Professor Katina Michael. Lindsay, and I thank you so much for your presentation.
You're welcome. Thanks, Robert.
It's no secret, I'm a big fan of yours, Lindsay, and I'm so happy that you get to meet Rob again, and Marcus, but also Professor Lewis Kuhn, who I think you have so much in common with. Lewis, Lindsay's been working probably concertedly the last, I would say, 12 years or so. Of course, given his practical experience, many more years than that, but particularly on his research, which, you know, you'd think that some things that generally come as common sense to engineers in the field would be well documented. But I think Lindsay's gone and championed a lot of that written documentation and is doing it with fervor, where he's looking at exposure and technology systems, how we build more robust systems, very much to do with the socio-technical side. And it just reminds me, you know, often we talk about the social implications of technology, and I read a paper about 6 months ago that said, okay, we can talk about the social implications of technology, but what about the social implications of technology? So it was like emphasizing the technology part. And I think Lindsay's done that. He doesn't use the socio-technical term very often, or at least he didn't in his PhD thesis. It was more about technology systems and making technology systems more robust. But increasingly, I'm seeing that he's creeping into that socio-technical space now. And I think as part of this discussion that Roba had with the IEEE Socio-Technical Systems Committee and your presentation, Lewis, the critical infrastructure, the interdependencies, these are all things that Lindsay's preoccupied with, and his call for collaborators is awesome because he's got a quantitative and qualitative skill set that I think SSIT could harness to do amazing things in the field and also in communication. So thank you, Lindsay, for that wonderful presentation on vulnerability. We are going to hit the paradox of security later today in the Hong Kong leg, but for now, that's all my reflection, Roba.
Thank you so much, Katina, and thank you again, Dr. Lindsay Robertson. So much to unpack there in your talk, and I hope we have an opportunity to do so in a future setting, in future forum for discussion.